So now we're going to talk about the many forms that quasi and natural experimental studies can take. And there are lots of them. And they're basically different ways to make comparisons of those who get the treatment and those who don't, or between people who get different treatments or groups who get different treatments. Or different values of the independent variable. Sometimes the independent variable is quantitative. So these forms are both about what happens in the real world. Like, oh, we rolled out our program sooner for this group than that group, or this state has different laws than that state. So it's partially about reality. And then it's partially about the data that you collect and analyze it. And it's also about how you analyze the data, what you do with it. So there's multiple aspects to these forms. But you want to always start with kind of who, what, where, when is getting the treatment and who isn't, or, who, what, when is getting some values of the independent variable versus others. Those can be comparisons over time, longitudinal ones. They can be comparisons of individuals or group at a point in time, a cross-sectional study. It can combine both of those, like a difference in difference study. And there are a lot of other variations. We'll only talk about some of the most important ones. So the simplest study, and the one you've almost certainly heard examples over time, is a before and after study, or just comparing a single group at 2 points in time. Like, oh, look at our productivity before we had the new scheduling system and see how much higher our productivity is after we introduce the new scheduling system, right? Or, in politics, how well is the economy doing under this president versus under that president? So that is often called a pre-post test comparison. And implicitly or explicitly, people are saying, hey, the effect of this new program or treatment or president or whatever is the difference in the outcome. So it's the outcome before, on average, minus the outcome afterwards. The example we had in the book was asthma before and during the Olympics, because the Olympics shut down traffic. And so the idea was, oh, well, we look at the asthma rate after the Olympics stopped traffic minus the asthma rate before, and then we can see the effect of such a dramatic decrease in traffic on asthma. That's the idea. So we show that, it's pretty simple. Here's the time, the treatment, there's before, there's after. But there are some problems with that. Before is used to estimate the counterfactual. So one is you're assuming the change in the independent variable causes the change in the dependent variable. But researchers don't control the world. Other things are happening. People mature, history changes, behaviors, events change. Think about that Olympics example. Well, some people left town because they could rent their homes out for lots of money to people coming to see the Olympics. So it's not the same population that was in Atlanta. Number of the people who live there, they left, and a bunch of visitors changed. Not comparable. Other stuff changed. So we're assuming that the change in the independent variable causes the change in the dependent variable. But other stuff is going on. In this case, the Olympics that drove the traffic change drove other things that could have affected the dependent variable. So that's kind of like this. Whatever caused the independent variable would have change the dependent variable anyway. It's not fully exogenous. So another one of my favorite examples is you have, oh, the new director of your not-for-profit comes, changes the scheduling, productivity improves. The director thinks, oh, the scheduling change improves the productivity, but the new director is like this inspiring leader who motivates people, improves productivity in lots of other ways. Just like, hey, maybe the Olympics changed who was in Atlanta, which would change the people who are more susceptible to asthma, to people who have asthma. You know what? It wasn't just the traffic. So very similar to a pre-post is an interrupted time series. Same thing, we're looking at before versus after, but we got a lot more time on other side to see if the change is part of a trend or real data. So whenever possible, you want to get prior time trend data. Another reason your organization wants to be measuring all your important outcomes regularly and in a consistent way so you can look at those prior time trends. And the easiest way to see this is a picture. So here's the time where the treatment starts and here's the outcome. And we see that in the case of A, the outcomes have been improving. We have this new treatment and they keep improving at basically the same rate. Doesn't look like the treatment added everything. But you see, if we only had one before point and one after point, we might have thought it did. But by having the longer trends beforehand, as well as afterwards, we can tell that this improving outcome was just part of a longer term trend. Contrast that with case B. Outcomes were pretty much bopping around, doing nothing good in terms of a trend, just some noise. Then we have this new treatment, new scheduling program, whatever. Suddenly, oh my gosh, look how much better we're doing. Real big improvement. And then we keep bopping around. Maybe it's going up slightly. Maybe there's a new trend from the treatment. Maybe it takes a while to fully affect. But basically, by looking at this data, you can see it's very suggestive that there's, the treatment was effective. Of course, you have to ask yourself what else happened at the same time. Remember my example with getting the new executive director who's doing lots of great new stuff. So this is suggestive that this point in time was really important, but you do have to ask, what else happened at exactly the same time. Another kind of study is like the residential management one in public housing is a cross-sectional study. So you're making comparisons of different individuals or different groups with or and without the program, or with different values of the independent variable at the same point in time. So now the idea is that another group, those without the program, are telling you the counterfactual, telling you what would have happened to those with the program if they hadn't had the program. So here you need the idea that the groups have to be comparable in ways relevant to the dependent variable, as we said. So one of the examples we had in the book, a natural experiment example, was the noise and learning study, where there's a school and one side of the school is right next to these elevated trains, and is very noisy, and the other side of the school is much quieter. And then they look at learning measured by test scores on the different sides of the school. And they basically say, well, the effect of noise on learning is the mean test score on the noisy side minus the mean test score on the quiet side. And they talk about the fact that they have investigated and ascertained that students were randomly assigned to the different sides of the school. So that's great. You've got your comparability of students, which is obviously critical. But you need all the other things that drive learning and test scores to be comparable. So I always wonder, what about the teachers? If I'm a teacher in this school, what side do I want to be on? I want to be on the quiet side. So maybe the more senior teachers get the quiet side, and maybe they're better teachers. The noisy wheel teachers get the quiet side. And if they're noisier about getting other better resources for their students. So again, what do you need for this to work? You need, for the most part, that everything that affects learning and test scores is comparable on the two sides of the school. So now let's go back to the resident management and public housing example and try and judge its internal validity. And the first thing you're going to look at are the comparability in terms of the measured variables. So again, what happened to these researchers, which included my co-author, Greg, in his earlier career, is basically the world sort of gave them the public housing complexes, which were getting resident management, and they had to go out and do their best to just find a comparison group. And this is what they got. You can see, like, here's the average age of the householder. You see the star. You see that it is statistically significantly different at the 5% level. And you have to ask yourself, okay, so that's about, 5.5 years different. Is that important? Does that matter in a practical sense for things like the safety and livability and so on? Household size, very similar. Education, very similar. Household income, really low. This is decades ago, but it was still really low decades ago. And statistically significantly a bit higher in the treatment group. Fewer male-headed households. Overwhelmingly non-white in both cases. Moderately large difference in Hispanic. The comparison group is 14 percentage points more Hispanic, and the treatment group is more married. So you're kind of stuck saying, well, is this close enough? Are these important things for driving the outcome? In which direction? Even more important, as I said before, you need to kind of look into unmeasured variables and why they might be different. And the key is doing some shoe leather, some qualitative work into understanding why these public housing residence complexes, how come they got the residential management. So this is not a strong quasi-experiment. It's a somewhat weak quasi-experiment, but often it's the best you have. And it's still a lot better than nothing. So when they did this, what did they find? Well, here are some outcomes. So here we have the building maintenance index, the security index, the housing satisfaction index. These are outcomes. We compare them between the treatment and comparison group. All the scores are indexes, remember that from the measurement chapter, on a scale of 0 to 100. So they have no natural units. They basically ask the residents a bunch of questions and they combine them into an index. So what is the effect of the program, of the residential management program, on building maintenance? Well, we take our 63.3 minus 50.2, and we see that our estimated effect of residential management on building maintenance is 3.1 on a 0 to 100 scale. And you should calculate the other effects from the table yourself, especially if you're not familiar with this kind of thing, just to make practice. Which ones are statistically significant? the two with the stars, the building maintenance, the housing satisfaction. What about practical significance? How would you judge that? So remember our sort of 4 general strategies for practical significance. Proportional effect is number 1. Well, 13.1 divided by, to make it the comparison group, the baseline, you can think of it as the no intervention or control, that's like 26% change. That's really not bad proportional increase. But, that's only one way of looking at it. You'd also want to look at an effect size, looking at this relative to the standard deviation. Don't have the standard deviation right here. What about comparing it to other programs? How well do other kinds of programs do on improving building maintenance, security, and so on? How does residential management compare? That's other information you'd want to know to judge practical significance. You also would like to make some connection to what this means in real life. Like, what kinds of real world things changed in building maintenance to do this? Was it elevators that had been out constantly that were working? Or was it just cleaning up a few small things, a slight difference? So what does that mean in real world on the actual maintenance, and how does that translate into people's lives? So those are the kinds of things you'd want to know for in any case. Now, a few points going back to the longitudinal studies that I want you to understand, because sometimes they can be confusing. The longitudinal studies are always conducted over time. That's what it means. But there are some different ways of doing that. One type of longitudinal study, like the before and after ones or the interrupted time series, involve looking at the same outcomes over time. We're measuring the same thing many times over time, and we can look at differences in the outcomes and see how they relate to treatment. A different kind of longitudinal study isn't like that. Its design, its causal estimation, is basically cross-sectional, but we're following the same subjects over time to observe long-term outcomes. So remember the Perry preschool study in the randomized experiment chapter, where we followed the same students over decades to observe their earnings as an adult and their employment as an adult. But we're still doing a cross-sectional thing. We're comparing the adults who once had the high-quality preschool to the adults who once didn't and just got whatever was readily available at the time with no help. So cross-sectional analysis. Why am I making a big point about this? 2 reasons. First of all, you'll see a lot of different researchers from different backgrounds talking at cross purposes. They'll say a longitudinal study, but they mean different things by it. Often in EPI, this one with the different outcomes, they'll call that repeated outcome measures. Because in EPI, they often think of a longitudinal study as one where you're waiting for a long-term outcome. The other reason is just always think, just kind of describe in everyday real-world language what is actually happening. What's happening? What are you measuring? What are you calculating? Particularly in these like simple comparisons, subtraction, that kind of thing. Another distinction I want to make about longitudinal studies are the prospective and versus retrospective studies. In a prospective study, you start a group called a cohort, like your cohort that started the MPA at the same time. You follow a group over time and observe what happens to them. So that's always well before the outcome. like I was talking about those studies where the outcomes are way after the treatment. And ideally, they're even before the independent variable, before the treatment program exposure in the language of epidemiology, but always before the outcomes. In a retrospective study, you find a group and you go back and you track down the earlier data. So many natural experiments and many case control studies that we talked about in observational chapter, those are often retrospective studies. Prospective studies are always better, but they're not always possible. They're better because you're sure you didn't lose anyone. If you define your population retrospectively, you might not find all the people you would have gotten prospectively. So that's often why they're better. Okay, so that's it for the sort of basic building block forms of natural and quasi experiments. Next, we're going to combine the cross-sectional and the longitudinal, the time dimension, to look at difference in difference studies.